This is the video for section 2.1 notes, slides 2 through 5. All right, so first part to start off says find the derivative of each function. All right, so we recall from section 1.7 and 1.8, the derivative is found by taking the limit as h approaches 0 of f of a plus h. So in this case, we're just going to leave x as x, and we're going to say 3 times x plus h squared minus 3x squared divided by h. So remember, this is the limit as h approaches 0 of f of x plus h minus f of x over h. Now, what does this find? This finds the derivative at x, at any value of x. All right, so how do we do this? Well, first step is to multiply out the x plus h. So the limit as h approaches 0, 3 times x squared plus 2xh plus h squared, all minus 3x squared, all divided by h. All right, so the limit as h approaches 0, so we distribute the 3, and then we subtract the 3x squareds. So that means I'm left with 6xh plus 3h squared over h. So now I'm going to factor out h, so the limit as h approaches 0, factor out h, and I get 6x plus 3h, all divided by h. So the h is reduced, and now I want to re-evaluate with h equals 0. So that means that I get 6x plus 3 times 0, or 6x. So if y is 3x squared, y prime is 6x. All right. Now we want to do the same thing, but now with y equals 5x cubed. All right, so once again, I'm going to start off. Limit as h approaches 0 of 5x plus h cubed minus 5x cubed divided by h. So I'm going to multiply x plus h cubed out. Now, yes, this means x plus h times x plus h times x plus h. But you should recall from pre-calc when you did the binomial theorem that x plus h cubed actually multiplies out to be x cubed plus 3x squared h plus 3xh squared plus h cubed. And then I have the minus 5x cubed, and then all divided by h. So now I'm going to distribute the 5, and then I have 5x cubed minus 5x cubed, so those are going to subtract out. So the limit as h approaches 0 of, if I distribute the 5, I get 15x squared h plus 15xh squared plus, not 15, plus 5h cubed, all divided by h. So now, just like earlier, I'm going to factor out h. So I have h times 15x squared plus 15xh plus 5h squared, and then all divided by h. So now h is reduced, and then I'm going to re-evaluate with h equals 0. So I would get 15x squared minus 15x times h, which is 0, plus 5 times 0 squared. So I just get 15x squared. So that means if y is 5x cubed, then y prime is 15x squared. So do we recognize a pattern? 3x squared became 6x. In other words, it became 3 times 2x to the first, or 6x. And the second one, y was 5x cubed, and y prime became 15x squared. In other words, we would say 5 times 3x to the second. So, do we recognize a pattern? So, let's say that y was equal to 8x to the fourth. What would y prime be? Well, if we follow the pattern, it would be 8 times 4x cubed. Let's see if you recognize the pattern. Y equals, let's say, 6x to the fifth. What would y prime be? It would be 6 times 5x to the fourth. Or in other words, we would write 30x to the fourth. So hopefully you see the pattern. So if we move on, we can generalize this. On slide number 3, we generalize this as the power rule. So if I want the derivative of x to the n, where n is some number, then I find the derivative by taking the n as the coefficient, and I take x to the, well, what do I do with the n now? I reduce the power by 1. So the derivative with respect to x of x to the n is n times x to the n minus 1. Now, what if there was a constant? So let's say that I had the derivative with respect to x of c, some constant times x to the n. Well, it's going to be that constant times n times x to the n minus 1. So the big idea here is that we multiply whatever the function is by the power, and then we reduce the power by 1. All right, so now, okay, the directions of these problems say find dy dx and d squared y dx squared. All right, so what do you think that means? Well, that is really just finding the derivative of the derivative. So dy, so d dx of dy dx. So in other words, we're finding the derivative of the derivative, which we refer to as the second derivative. Now, the way we read this is d squared y dx squared. Now, if we were using prime notation, we would say y leads to y prime, which is the derivative, and then y prime leads to y double prime, which would be the second derivative of y. Or you could keep going and you could say, well, y triple prime would represent the derivative of the second derivative, or the third derivative of y. And we could keep going. All right, so anyway, if I want to find dy dx, how do I do it? Well, I've got 3x to the fourth plus this other thing minus this other thing. So what we're actually going to do is we're simply just going to take the derivative of each term separately. All right, so if I have 3x to the fourth, how do I find its derivative? I bring the 4 in front and multiply by 3, so I get 12x, and then I reduce the 4 by 1, so I get 12x cubed. Okay, but now, these next ones are a little bit more challenging. So 6 times the third root of x. Well, what is the third root of x? So you need to remind yourself, okay, I'm going to write this on the side. The third root of x could be rewritten as a power, x to the 1/3. And so if I have x to the 1/3, then I'm going to go back here. I have plus 6 times. Now, what am I going to do with the 1/3? I'm going to bring the 1/3 in front. So it's going to be 1/3 x to the what? So now I'm going to reduce 1/3 by 1. So 1/3 minus 1 is actually negative 2/3. Then I have minus 7. So keep in mind, 7 is really like 7x to the 0, right? So if I multiply 7 by 0, I get 0, right? So another way to think about this is 7 is a constant, right? So it's like a horizontal line. So what is the derivative of a horizontal line? Well, that is 0, right? The slope of a horizontal line is 0. All right, so continuing on. All right, the next one. Okay, I've got y equals x to the 6th over 2. Now, before I do this one, I'm actually going to think about this and rewrite it as 1/2 x to the 6th. If we realize that 1/2 is just a coefficient, that makes it a little easier. Same way with 2/3 x cubed plus 7x. Now, what about this? Okay, 3x to the negative first. Well, I'm going to leave that alone, but what is 3x to the negative first? It's actually like saying like 3 over x. So if we had 3 over x, I would have wanted to rewrite it as 3x to the negative first. All right, so now notice this is still y. So now I'm going to take the derivative. So dy dx. All right, so half of x to the 6th. So I'm going to bring the 6 in front. So half of 6 is 3x to the 5th. Minus, now I have 2/3. So 2/3 times 3, well, that's just 2x squared. All right, 7x. Remember, this is like 7x to the first. So I bring the 1 multiplied by 7, so that'd be 7x to the what? Well, x to the 0. We reduce 1 by 1, so we get x to the 0. So actually, x to the 0 is just a constant, so we leave that alone. And then minus, now I have 3, and I'm going to multiply by -1, so that actually becomes plus 3x to the, now I'm going to reduce -1 by 1, so that becomes -2. All right, so these are the dy dx's. Now, it also then asks us to find d squared y dx squared, so that would be the derivative of the derivative. All right, so now, this is dy dx, 12x cubed. So what do? I bring the 3 in front, so that would be, so I'm going to write d squared y dx squared. All right, so 12 times 3 is 36 x to the what? I reduce the 3 by 1 now, so that becomes 36x squared. And then this was 6 times 1/3, or that's 2. So then I have plus 2 times what? Well, now I bring the -2/3 in front, so 2 times -2/3. And then x to the what? I reduce -2/3 by 1. So -2/3 minus 3/3 is -5/3. And so I might just finish that off and simplify that part at the end. So 36x squared, and then this would become minus 4/3 x to the -5/3. All right. The bottom one here, second derivative, d squared y dx squared. All right, derivative of 3x to the 5th, that would be 15x to the 4th, minus 2 times 2 is 4x to the 1st, plus, what is the derivative of 7? Remember, that's a constant once again, just like we did up there, so it's actually 0. And then plus 3 times, well, I would bring the -2 in front, so times -2. And then x to the, I reduce -2 by 1, so it becomes -3. All right, and so I might just simplify that as 15x to the 4th minus 4x, and then minus 6x to the -3rd. All right, so that's the first derivative dy dx and the second derivative d squared y dx. That should say dx squared up there. I apologize. All right, so that is the basic power rule. All right, so now on slide number 4, okay, next, we're talking about the product rule. So the product rule refers to when we have two functions that are multiplied together. So this one says the derivative with respect to x of u times v. So basically, this means we have two functions that are multiplied by each other. So when we look down here in the example, I have 3x plus 7 times x cubed minus 4x minus 6. So two things that are multiplied together. All right, so the product rule, all right, is we take u and multiply by the derivative of v, so dv dx, plus v times the derivative of u, du dx. All right, and so the way I remember it is just say first times derivative of the second thing, so the first function times the derivative of the second function, plus the second times the derivative of the first. All right, and so first times derivative of the second plus the second times the derivative of the first. So that's, you might just want to say that to yourself. All right, but, okay, so 3x plus 7, that's acting as u, and x cubed minus 4x minus 6, that's acting as v. So f of x equals this, so find f prime. All right, so f prime of x equals what? Well, we're going to take u, so that's 3x plus 7, and multiply by the derivative of v. So derivative of x cubed, that's 3x squared, minus the derivative of 4x. So remember, that's like 4x to the first, so it'd be minus 4 times x to the 0, and then minus the derivative of 6. The derivative of 6 is 0. So that is like u, and then dv dx plus, now I'm going to take v, which is x cubed minus 4x minus 6, times the derivative of u. So this is, remember, v times du dx. All right, so derivative of u then is going to be, well, what's the derivative of 3x plus 7? So derivative of 3x is going to be 3 times x to the 0 plus 7. The derivative of 7 is 0. So this would be f prime of x. Now, of course, we could multiply this thing out and simplify and all that, all right, but this technically would be the derivative. All right, now, let's say that we did choose to multiply it out. F prime of x. All right, so 3x times 3x squared, that would be 9x cubed plus 21x squared minus 12x. And then minus 28. So we would get all that. Then we have this other part, plus 3x cubed minus 12x, and then minus 18. So we could technically simplify this further. F prime of x, I have 9x cubed, and then I have a 21x squared and a 3x squared, so plus 24x squared. I have a minus 12x and a minus 12x, so minus 24x. And then I have a minus 28 and a minus 18, so that would be minus 46. Now, any one of these versions is correct, but did we have a different option for finding this derivative? So what if, instead of taking the derivative, what if we just multiplied f out? So f of x could have been multiplied out, right? So 3x times x cubed, that would be 3x to the fourth. And then I have 3x times minus 4x, that would be minus 12x squared. 3x times minus 6, that would be minus 18x plus 7x cubed minus 7 times 4, so 28x, and then minus 7 times 6, minus 42. So now, if I were to combine my like terms, I have f of x would be 3x to the fourth minus, I've got a plus 7x cubed. I just like to write it in descending order, minus 12x squared. And then I've got the minus 18x and the minus 28x, so minus 46x and then minus 42. So now that's still f, but then if I took the derivative like we did on the previous slide, I would get 12x cubed plus 24x, not 24, I apologize, 21 x squared minus 24x and then minus 46. All right, so looks like I made a mistake somewhere in my work earlier. I had a 9x cubed and a 3x cubed. That should be 12x cubed.